Hello students, this is second part of my presentation from chapter 1, Chemical Reactions and Equations. In this, we are going to study the various types of chemical reactions and their examples. It becomes very easy to understand all the types of reactions if we visualize this figure. Here, chemicals are represented by English letters A, B, C and D. After understanding this, we can replace the letters by the name of chemicals of the reactions which actually undergo chemical reaction. In the first figure, we can see chemical A and chemical B combines to give a single product AB. This is an example of combination reaction. In the second figure, we can see the compound or chemical AB breaks or decomposes to give two separate components A and B. This is an example of decomposition reaction. In the third figure, we see that chemical AB reacts with chemical C. After reaction, C takes the position of B, forming AC and B. This is an example of displacement reaction. In the last figure, we see two compounds AB and CD are reacting. After reaction, B takes the position of D and D takes the position of B, forming two compounds AC and BD. This is an example of double displacement reaction. Let us study each type of reaction one by one to clearly understand them. The first type is combination reaction. Combination reaction is a reaction in which two or more elements or compounds combine to give a single product. Let us see an example. Oxygen here is combining with hydrogen to give water. Now, why 2 is written before hydrogen and before water? This is to balance the chemical reaction. This I have also explained to you in my earlier presentation of chapter 1 part 1. So the reaction becomes 1 mole of oxygen combines with 2 moles of hydrogen to give 2 moles of water. So here we see the product is water only. Moles are 2, but product is only water. So this is an example of combination reaction. Some more examples of combination reaction. In the first reaction, element magnesium and oxygen combine to give magnesium oxide. In the second reaction, carbon element combines with oxygen to give compound carbon dioxide. In the third reaction, element hydrogen and chlorine combine to give compound hydrogen chloride. And in the last reaction, compound calcium oxide combines with water to give compound calcium hydroxide. Have you observed any difference in all these reactions? You can see in the first three reactions, elements are combining to give a single product. But in the last reaction, compounds are combining to give a single product. So the definition of combination reaction becomes, in a chemical reaction, if either elements or compounds combine to give a single product, it is called combination reaction. This is the second type of reaction in which a compound breaks or decomposes into its constituent elements or compounds. Here I have taken the example of water, which decomposes to give hydrogen and oxygen. Why I am using 2 here? This I have explained to you in my earlier presentation of chapter 1 part 1. This is to balance the chemical equation. The same is shown in the figure also. 2 moles of water molecules decomposes to give 2 moles of hydrogen and 1 mole of oxygen. Some more examples of decomposition reactions. In the first reaction, silver chloride is decomposing into silver and chlorine. In the second reaction, calcium carbonate is decomposing into calcium oxide and carbon dioxide. In the third reaction, iron hydroxide is decomposing into iron oxide and water. And in the last reaction, lead nitrate is decomposing into lead oxide, nitrogen dioxide, and oxygen. Have you noticed any difference in these reactions? See carefully. In the first 3 reactions, the compound is breaking into 2 elements or compounds. These are 2 elements and the rest are compounds. These are compounds: calcium oxide, carbon dioxide, iron oxide, and water. These are compounds. But in the last reaction, lead nitrate is breaking into 3 components. 2 are compounds and 1 is an element. That means the definition of decomposition reaction becomes: a compound decomposes into 2 or more elements or compounds. It is called decomposition reaction. Now, why the compound will decompose or break? That also depends on many factors. This reaction can take place because of sunlight. The reaction can take place because of electricity. The reaction can take place because of heat. So all these reactions take place because of a specific condition, either heat, either light, or electricity. This is the third type of reaction in which a reactive metal displaces a less reactive elements from its compound. Here I have taken the example of iron and copper sulfate. Iron is more reactive than copper. So iron displaces copper from copper sulfate and make iron sulfate and copper. Imagine if the reaction would have been between iron sulfate and copper. No reaction would take place. Can you guess why? Because copper is less reactive than iron. So copper would not be able to displace iron from iron sulfate. Some more examples of displacement reactions. First reaction, potassium is combining with magnesium chloride to form potassium chloride and magnesium. In the second reaction, zinc combines with hydrogen chloride to form zinc chloride and hydrogen. And in the last reaction, zinc combines with copper sulfate to give zinc sulfate and copper. In all these reactions, the reactive metal displaces. Potassium is more reactive than magnesium, so it displaces magnesium. In the second reaction, zinc is more reactive than hydrogen, so it displaces hydrogen from hydrogen chloride. Third, zinc is more reactive than copper, so zinc displaces copper from copper sulfate, making a new substance. So the definition of displacement reaction is: if a reactive metal displaces or substitutes a less reactive metal from its compound, it is called displacement reaction. The fourth type of reaction is double displacement reaction, in which 2 salts react together to form 2 new compounds. When the 2 salts react, the ions of these salts exchange their positions. I have taken the example of barium chloride and sodium sulfate. You can see here barium chloride, when it reacts with sodium sulfate, barium takes the position of sodium and sodium takes the position of barium, forming barium sulfate and sodium chloride. So the reactions in which ions are exchanged between two reactants forming new compounds are called double displacement reactions. Let us study some more examples of double displacement reactions. In the first reaction, potassium nitrate is reacting with aluminum chloride. After reaction, potassium takes the position of aluminium and aluminium takes the position of potassium, forming aluminum nitrate and potassium chloride. In the second reaction, silver nitrate is reacting with potassium chloride. After reaction, we see silver takes the position of potassium and potassium takes the position of silver, forming new compounds silver chloride and potassium nitrate. In the last reaction taken here, sodium hydroxide is reacting with hydrogen chloride. After reaction, we see that sodium takes the position of hydrogen and hydrogen takes the position of sodium, forming new compounds sodium chloride and water. So in all the above reactions, both the ions of reactants exchange their positions, forming new compounds. Such reactions are known as double displacement reactions. In many of these reactions, an insoluble salt is formed. Insoluble salt is known as precipitate. This is represented by an inverted arrow. This is explained to you in my presentation of chapter 1, part 1. Dear students, my next video will be on oxidation reduction reactions, endothermic and exothermic reactions, and reactions which are important from examination point of view. So keep watching my video and subscribe my channel. Thank you.